Hello and welcome to this manufacturing systems technology module 38. We were talking about the various steps of an NC program, and we were generally concerned with what are the broad categories in which you can actually divide the different commands of an NC program. So, I think we had mentioned in the last lecture that there are preparatory functions, for example, which are also known as the G functions. There is an axis motion command which is the X, Y, Z kind of functions. There is a feed speed which is Fs kind of functions, and then there is an identification command which is the N. Obviously, the sequence is as per the format of the controller that we had shown in the last module, and then there is a miscellaneous command which is defined by some M or something. Okay. So, now let us put together by first delving into the independent entities, like let us say what are the different kind of miscellaneous commands, or what are the different kinds of preparatory functions, or what are the different kinds of, let us say, even the motion controls like X, Y, Z or I, J, K kind of motion controls. And once we have done that, then we are enabled now and we understand the sequence in which we have to write the blocks independently, so that you can now do a construct of the program. Okay. So, preparatory functions, they are largest class of commands actually in the NC program, and in fact these are the commands which are typically used for preparing the tool position with respect to workpiece. Okay. So, this is how mostly these G commands or preparatory commands are used. You are preparing the tool position with respect to the workpiece. So, they are identified by the word address G followed by 2 digits. 2 digits mean that there is a capability that the controller can handle about 100 such G commands. Obviously, all the requirements related to what is the coordinate axis in which the motion should happen, or what is going to be the units in which the motion is recorded, whether it is in millimeters or in inches, whether it is absolute units or incremental, all these angles need to come when we are preparing the tool motion with respect to the workpiece. Okay. So, therefore, the G00 to G99 are in fact independently maneuvered 100 such commands, which some of them are very widely used, some of them are probably not very often used or even used only once, but they are all related to how the tool will need to get positioned with respect to the workpiece. And this position has the definition of all the metric units or systems, and whatever the measurements are in, whatever the relative motion is in, whether it is incremental or absolute, all those definitions should be contained typically within the preparatory functions. So, in general, the preparatory functions have the effect of making the MCU assume specific operating conditions or command the controller to perform the next task in a particular manner. So, they are basically one of the first set of commands which need to be there in a block for the block to get initiated or started in terms of its execution. So, just following the identification number N, there has to be the preparatory function enabling the system of motion which is governed by all these stepper motors etc. within the machine to start getting prepared to do its job of the relative motion. Okay. So, that is why preparatory, that is why the name preparatory. So, it is usually permissible to program more than one preparatory words in a block, as long as the words do not have the conflicting effects. For example, you cannot use in one block that some G code says that the measurements is in inches and some says it is in meters. Okay. That kind of a sequence is not permissible. Otherwise, if you want to use 2 different G commands, one giving the aspect of let us say inches coordinates, and another giving the aspect of the absolute motion or the incremental motion, that kind of a sequence of G in a same block is allowed. So, you can use more than one such G commands to prepare the motion at different levels or for different aspects, but one aspect cannot clash in a single block with respect to each other. That you have to be very careful while using the preparatory commands or multiple preparatory commands within the single block. So, let us look at some of the very widely used or commonly used G codes which are available. So, for example, G00 actually signifies a point to point positioning at a high rate. G01 similarly signifies a linear interpolation at a controlled feed rate. I am going to illustrate the difference between G00 and G01 in great details in the next slide, that what exactly these two are. G02 is circular interpolation. So, whenever there is a need for a an arc to be executed, symmetrical arc to be executed, you go for this G02 option. So, you can have the circular interpolation in either the clockwise or the counterclockwise direction. So, obviously, this has to have two different preparatory modes. So, G02 is the circular interpolation clockwise and the G03 is circular interpolation counterclockwise. Then you have a G04 for a dwell for a program duration option, that whenever you have this and you need that the tool dwells in a certain place for a certain amount of time, use the command G04. Okay. So, there is also a G command for selecting the XY plane. So, G17 selects the XY plane, G18 selects the YZ plane, the G19 selects the XZ plane. Particularly if you want to do something in a block which has all these three different planes, it would be very easy to just offhand mention the preparatory function G17, indicating okay, whatever has to be done is in the XYZ, the XY plane, something like that. So, then you have G commands representing the basic dimensions. For example, there is this G70 for example, which represents inches unit. So, now once you have programmed G70, every reading that the controller will be interpreting from the numbers that you are feeding on the system as a programmer would be taken in inches, quote unquote. Okay. Similarly, G71, which indicates metric units, where every reading that you as a programmer would be punching in the system would be taken to be in meters or millimeters, actually millimeters. That is how metric system would be. Okay. G90 for example is absolute dimensions. So, here what it means is that I already told you before that the coordinates can be interpreted either by looking at the origin, and from from the origin how the coordinate is placed, and it can also be looked into as an increment or a difference between the previous position and the next position. So, in one mode it is called absolute, another mode called incremental programming. So, similarly, if the controller is capable of, or the controller is commanded to follow the absolute dimension strategy, then it is going to automatically read whatever you punch in the x, y, z values as the coordinates. Okay. And if it is actually in the incremental mode, then obviously it will take the x, y, z value to be the next particular x, y, z where the tool has to be. And here there may be a little problem, because if there are multiple tools and multiple operations happening, there is going to be a problem about cross interference between the tool paths. So, typically all the NC controllers have an enabled simulation platform which is associated with the machine, where wherever code you have been executing, that will first get validated through this motion sequence which otherwise gets simulated, and then once the tool path is considered to be a good tool path, only then it is feed forwarded to the NC system or the NC machine. Okay. So, there are capabilities like wise which are associated with all machines operating in the NC environment, and in fact the programmer's job becomes reasonably simple, because now he can program and see if his program is going to work. Okay. So, there is a validation which is provided by such a platform before actually finally feeding the program into a NC system, and otherwise if you had such an interference, the tool axes would be damaged. Okay. So, that has to be somehow prevented using this particular mechanism. So, that is what the preparatory functions are. There are also we try to just answer that question that I left earlier about the linear interpolation as opposed to the rapid point to point positioning or the rapid positioning. So, let us now look at the difference between G00 and G01. Here is an illustration right in this figure which talks about such positioning and linear interpolation. Okay. So, let us look at the fundamental of a CNC or a NC system. I had discussed earlier that basically an NC machine is nothing but a retrofitted normal machine. Okay. I had also illustrated in great details that there are going to be principally two different control mechanisms. One is an open loop control mechanism, another is a closed loop, and there I had illustrated that all the motions therein, which are relative motions between the tool and the workpiece, are going to be there by virtue of lead screws and some rotation provided to those lead screws by motors, which can be either DC motors or stepper motors. So, in case of closed loop control, for example, it is mostly done with the DC motors, because there is a resolver which needs to be used, and the motor is, although a high torque, it provides the high torque for machining, etc., but it is really not enabled to position accurately, and there is always going to be an overshoot or undershoot because of the inertial component of the motor itself. Okay. Similarly, in case of stepper motor, as I told, it is normally used for open loop. There is no such resolving sensor which would allow for the position, etc., and you already know for sure that if you have given these many pulses, this is exactly the precision with which the motion would take place, and it will reach a point with certain precision, and you forget about it. You do not really need the positioner data or position data again to sort of backtrack it back to the original position, because you already know that it is precisely positioned. Okay. So, these are the two modalities with which all the NC systems operate. I had illustrated in lot of details earlier. Now, think of it that supposing you want to execute an XY motion on such a tool system on a NC machine, and there are, for that purpose, there are two lead screws which will take a table, probably let us say the work table, and the work is moving relative to the tool in this particular orientation. So, the work table is moving some distance along the x direction and some distance along the y direction by virtue of two lead screws, one moving the x direction, another moving or rotating in the y axis. So, that there is a lead screw based travel in both the x and y directions. Now, if these two motors are being operated at full speed, okay, typically we can assume that if the lead screw pitches are exactly similar to each other, and they are also both of them are either a single start or a double start system in terms of the lead screw, and they are identical as such mechanically. So, therefore, with equal rotations of motion per unit time, the lead screws would travel linearly in equal dimensions or equal distances. So, the x motion will be same to y motion, and there you would always get a 45-degree angle across which the final table would move, because the x and y is now happening simultaneously, okay, in a particular direction. So, the table moves at 45 degrees angle in that case, within the range obviously of the x and the y which the tool has been designed for, okay, and that is a very important aspect that I would like to consider here when we are talking about rapid positioning particularly. So, rapid positioning is a system where it is typically used when you need to have motion, because you want to align the tool at the start of the machining, or the start point where the machining should start to take place with the workpiece. Okay. So, you want to take the tool there without much delays, because obviously it is not machining while doing the positioning, it is merely a positioning that you are doing at that particular instance. Obviously, you want the tool to quickly as possible go to the start of the machining process, and therefore, you need to give it a rapid positioning aspect. So, having said that, now with all this knowledge which I have just discussed over the last about 5 minutes, think of it that if you had a situation where the x and y coordinates are not uniform in nature. For example, let us say we talk about a motion between the point A and the point C on this xy plane, and there are several ways to go to C. One is that you go from A to B and B to C. Obviously, if we look at the coordinate of C, the coordinates of C are basically 30 units in the x direction and 20 units in the y direction. Similarly, the coordinates of B here are about 20 units in the x direction and 20 units in the y direction, coordinates of A being about 5 units and 5 units the A and B direction, okay, respectively in the x and y direction respectively. So, you are essentially going from the point 55 to the point 30-20, and the constraint you have is that you have to reach the position C with rapid positioning. That means utilizing the full capability of the NC system with both the motors rotating, okay, so that you can make this traverse from A to C within minimum possible time. Okay. So, what you are essentially doing is that till and until it permits, till and until x is equal to y, it can go at full speeds on both the axes. For example, now with A and B on board, the A axis is rotating at the fullest speed and the B axis also is rotating at the fullest speed of the motor. Once it has reached B now, there is no more requirement to go in the y direction. So, only the full speed is operated along the x direction motion and the x lead screw goes for the remaining 10 units in between, so that it reaches the point 30-20 from the point 20-20. It is very important for you to gauge this point, that why I am calling it a rapid positioning. So, essentially you are splitting up the motion into a situation where the x and y's would move equal to each other at 45 degrees, beyond which one of the axis is limited, because you have already reached the fullest of one of the axis and the other axis is still needing to go. So, now you are having whatever balance you need to go on that axis with full speed of the motor along that particular axis. So, that is how practically you are moving the xy table from the position A to the position C at the minimum possible time. Although the path may seem to be, as drawn here, may seem to be more, obviously two paths in this triangular figure are, I mean, lengthwise they would definitely sum up to be more in comparison to the dotted line here, the third side of the triangle, but the figure does not illustrate that factor here. Okay. The figure only is saying that what is the time advantage you will get in moving 45 degrees and moving the remaining balance by full speed operation of all these stepper motors, vis-a-vis a case where you have to position linearly from A to C. So, the linear position really would be from A to C along the dotted line, as you can see here. So, this is the linear positioning and this is the rapid positioning, and the rapid positioning is basically G00 and the linear positioning is basically G01. So, it is very clear as to what our goal is here when we talk about rapid and linear. Obviously, linear positioning may be made in a case when the actual machining operation has began and you have to really feed it at a certain rate, because if you just simply are considerate of the overspeeding factor of the motors alone for the time saving aspect, the material may not behave in a similar manner. Every material has some kind of a residence time for the tool in certain places, or at a certain rate only the material can be machined to for the machining to be optimum, okay, and the tool wear to be the least. Okay. So, therefore, the linear positioning is typically used in those controlled aspects where the actual machining operation has started to take place. Otherwise, mostly for the positioning aspects, etc., the rapid positioning is formulated to be a very good tool. So, I think I am at the end of this particular module, I am going to take up some few more such detailed commands, like particularly the circular interpolation commands, before I proceed into actually looking at the program. Thank you.